Okay, good evening. Processing in the browser. At this point, you're probably wondering who on earth this guy is. If you are, my name is Nkosi. I'm a software engineer here at BBD. I work with Mike and Jerry in a unit called ATC. I'm not entirely sure what we do. On paper, they say we do research and development, we do consulting, and we do some training, or we facilitate something called learning. But they haven't fired either one of us yet. So I think we're doing okay. I studied at Wits, and because I seem to really have a high tolerance for pain, I went back and studied some more. So I'm currently pursuing an honors degree in game design from Wits University. But the most important thing for you to know about me is that my Twitter handle is at @nlucky_Nkosi. Feel free to follow me. Let me know what you think of this talk. So let's get to it. On tonight's show, we're going to be discussing just how beautiful these slides actually are. I mean, just look at all these colors, right? We're going to talk about the importance of good looks. We're going to discuss just how difficult it is to actually get good looks. What's the point of me telling you all of this if I'm not going to show you how to actually get good looks and to do it with ease, right? Last, definitely not least, I'm going to tell you one more time to follow us on Twitter, right? Because that's very important. Let's get to it, how beautiful these slides are. So I got these as a free template created by allppt.com on freepowerpointtemplatedesign.com. Feel free to go to the website and get some awesome stuff. I decided to give them a shout out because these slides are beautiful. Now, before I start, I need a favor from all of you. Everyone that has Twitter, while I speak, I'd like you guys to tweet, but specifically tell us what you think about this meetup tonight, what you thought of the beer. Don't talk about the pizza issue. Tell us what you thought of the talks. And at the end of my talk, I'm going to show you guys something really awesome with all of your tweets. In all of your tweets, remember to mention hashtag Jozi.JS. You can mention the account, you can mention me as well if you want, but don't forget the hashtag. And I'll show you something really awesome right at the end. See, now you want to stay for the end, right? Okay, let's get to it. Because you work in tech, I'll start with some buzzwords. The first buzzword I'll start with, gamification. This one is very important to me because of my game design background. If you ask 10 people in the room what gamification is, chances are you'll get about 3, 4, maybe 5 different answers. In essence, gamification is gamifying processes in order to make them seem like fun, like banking, right? But we do this so that we can create meaningful engagements with the people who use our systems. We do this so that people can come back and use our systems again and again so that we can make more money. We use them so that people can learn, so that the information we're giving to them actually sticks. This is being embraced in all sorts of industry. Education, banking. Actually, BBD helped one of the banks a couple of years ago design a kids banking app. It was actually a game to teach kids how to bank and manage their finances. They actually even used a game development engine called Unity 3D. We're even seeing this in the entertainment space. Traditional entertainment, like films, are taking game development elements to try and create much more engaging experiences. Let's talk about another buzzword, big data. I'm sure you've all heard a lot about big data and you all know what it is. It has all these points. The key point for me is the value. How do we extract value from all this data that we have being presented to us? The one thing that these two buzzwords have in common is that a big part of this value, be it from a game or the process of gamification or be it from big data, is that a lot of it hinges on what your user ends up seeing. You could write the cleanest, most efficient code, but if your UI is crap, people won't use it. And the system that isn't used is a failed system, because we build software not for computers, we build it for people. So take a look at this. This is how much data we generate in a day. How many of you actually read the slide when I put it up? I saw some of your faces go to the slide and come back to me, because you're like, those are a lot of words and he's probably going to talk about what's on the slide already. Take a look at this slide. Now you want to see how much data we generate. This is how much data we create in a day. And this is exactly what I'm here to talk to you about today. Presenter's view is actually very important. But anyway, Mike gave a talk at the last Jozi.JS about what should the web do. And he said that it's our responsibility as web developers to start thinking about these things. Where do we want to see the web going? While we do that, the people who use our applications on the web have already decided, actually. They want the web and the browser in particular to do everything. And they want it to do everything now. What does this actually mean for us developers? It means that the web has become this beast. That's more than just about transferring files from one computer to another. And the browser has become this thing that's so much more than just a way of viewing the files that you have on your machine. It's become a core means of engaging with all sorts of technology, not just websites. There's a fingerprint scanner on your phone. Guess what? Users want to use it on your browser. We now have to figure out how to integrate that fingerprint scanner into your browser. Come in web or thin. You now have an Arduino. Users want to use it with your browser. There's all these different things that are constantly coming up in the tech space that all of our users sitting here want to actually do it. And all we have is this tool, this leash to try and tame this beast called the World Wide Web. And that tool is the browser. And we need to make use of it to the best of our ability. So when all the crap comes along, we need to clean after it. We need to make sure that we have a handle on that crap in order to maintain this mighty, fierce beast called the World Wide Web. That's a lot of power. And with power, great power comes great responsibility. Particularly for us in the tech space. Take a look at the stat. You can start protests with the first slide. And you can let governments walk over people with the second one. This is presenting the exact same data. All they did was have a different Y scale. And they're painting an entirely different picture. This is the power of what visuals can do. Visuals can actually drive people into taking actions. And the way that you're presenting it can drive them to take different actions. Take a look at this stat. In the United States, between May and July of some year, the number of murders increased as ice cream sales increased. The US president might decide to curb murders. We're going to ban all ice cream sales, right? Because of the data that was presented to him. So us as people who are creating these experiences and are providing this data, we have the responsibility to make sure that we use our tools for the better, for best. So if we talk about people in the finance industry and maybe some of our business analysts, they probably use Excel spreadsheets to visualize all of their data or to make sense of it. I just usually see grids and numbers and I go, cool. So what must this thing do? Painters will have paintbrushes. Sketch artists will have pencils and their sketchbooks. What do we as web developers have? JavaScript, CSS, and HTML, right? As Mike would tell you, only JavaScript, nothing else matters, right? Take a look at this. This is not an out of focus image of the Mona Lisa. Okay, mouse cursor's gone. This is actually done all in CSS. This is rendered in CSS and I then took a screenshot of it. See, I knew that some of you wouldn't believe me, so I've got it running over here. And you can see all of the CSS on the side. I'll share this URL with you after this talk and once I get back to my slide. Cool. Right, now, while CSS, HTML, and JavaScript are the tools we have, I don't think all of us are this proficient in using CSS or have this patience, right? Now imagine for younger developers who are coming into the industry. The learning curve seems to be so high, or so steep rather. And with everyone using the web as their main means of engaging with technology, we're going to get more and more developers becoming web developers. And it's our responsibility as the people currently in the space to make sure that we can produce enough web developers. In comes a library called p5.js. This is one of the easiest ways that I've found to draw stuff on the canvas, to create images, and to really make things look good. Those good looks we started talking about. So what exactly is p5.js? Well, a long time ago, the year was 2001. A friend of mine told me that he interviewed someone who was born in 2001 this year, which is a scary thought for some people in the room. Right? Yes, and I can see the faces light up. 2001, processing was created. This was an open source Java library because people in 2001 created graphics with Java and C++. I can see the horror on some of your faces. And I think some of the We Think Code guys actually had to do that with C. But anyway, I digress. This was created to be a simple, or to create simple visuals. Over 10 years later, they realized, wait, people are still using this thing, and people have been contributing to it. And so they formed the Processing Foundation, which was charged with the development and distribution of processing. A year later, they realized that, wait, browsers are actually big and very important. We need to be able to use this thing in the browser. And so they created processing.js, which was actually a port. So people would write Java code, and then they would use regex to convert it to JavaScript and then run it, right? And then they realized that JavaScript developers actually love their divs and their A's and their H1s, and they probably hate Java, right? So they rewrote it. They redid the entire thing in actual JavaScript and called it p5.js, because processing was such a long word, right? They called it p5.js, and this came with a full set of drawing capabilities. They used a canvas, and they had full integration with the DOM. Well, I say full because they then later added a library that allowed you to create DOM elements from the library itself, or using the library itself. At this point, you're all probably thinking this guy's been blah, 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 blabbering. So to compensate for so much blah, blah, I'm going to live code. I wish I was as smart enough as Karen over here and just had slides. But anyway, let's see. This was a sacrifice for the devil gods, so I'm good. Cool. So let's take a look at p5.js. What I want to show you today is just how easy p5.js is. If you go to their website, let's actually open up. I was told that searching for stuff is usually very dangerous. Cool. And you'll see that on their download page, you can download the complete set of libraries, which includes all the add-on libraries that they only realized later that they actually needed. So I've already done this. I've got this in a folder. So I'm going to delete all of that because I promised you I'd live code. Jeez, shouldn't have done that. But anyway, so I'm going to create a new sketch. I'm sorry for shouting. So sketch.html, just an HTML page. Let's start with something very simple. Let's draw a circle, right? Because that's such an easy shape to draw, right? All the young dive guys like me are going, yeah, circle, circle. All the old guys are like, ooh. Right? So, I'm so quick at typing. Damn. Right? So, as you can see, this is a simple HTML page which has a canvas, right? Because we're sketching. We're going to use the canvas, and I get that canvas by ID. I get something called a 2D context, I begin a path, I create an arc with some numbers in it, I see pi, which is scary. And then, because circles, right? Yes. And then we stroke to get the O. So let's see. I'm gonna open this very basic HTML page, and we have a canvas with a circle. Yay! Woo! What a crowd. How easy is this to do with P5.js? It's not, because we still need HTML, right? So there, we've got some basic HTML stuff. So this isn't actually P5 yet. To prove to you that I'm not tricking you, I'm just going to get rid of the entire body. How's that? First thing we need to do is we need to add our P5 script. Let's see if I can find where it is. Nope. There we go. P5.js, just imported it. It's over there, as you can see. And I'm going to add a script. Okay, so when you start with P5, there are two functions that you'll almost always have. The first is called setup, and the next is called draw. Setup is called once when you first render the page. So that's where you want to have all your configuration stuff and the stuff that you need to be drawn first. The stuff that never changes. And draw gets called every frame. So that's where you generally want to have your state checks and stuff that changes with user input to be placed. If you've built games with Unity 3D, you'll recognize this sort of pattern. I think the start and update. If you've worked with Arduino, they'll have the exact same thing. They will have, I think it's setup and loop, if I'm not mistaken. So all we do here, we call an H5 function called create canvas. It takes in the position, it takes in the size and the renderer. Show you what I mean. If you do this, you can also get full IntelliSense of P5. That's how widely used this library is when it works. Okay, cool. So you can see your width, your height, and the renderer that you want to use. So we're going to use the default 2D renderer for now, and all we have now is a canvas. Because you might not believe me, I'm just going to make the background of our canvas black. And you'll see. There we go. Now we need to draw the circle. I'm going to draw an ellipse, which I'm told is a circle-like shape, which you can like bend and do all sorts of things depending on the width and the height. How big should we make it? 200. 200 by 200. Wait, that's the position. And then let's say 200 here as well. Let's remove the height because I think that's optional. Cool. Simple circle. Oh, yay! This is cool and all, but it doesn't really help. Let's add some events. Let's create a paintbrush. We've all played with paint, right? Where you just like pick a brush and you start drawing stuff. So we still do. Paint was discontinued at some point. So paint, add 3D, and it's a new system, right? Cool. So they've got built-in functions to pick up events and built-in variables to pick up state. So we can literally say if mouse is pressed. You can see that this was created for designers, right? Because the variables make sense. It doesn't say m underscore and all sorts of stuff, right? So if mouse is pressed, we want to, let's change colors, right? So to change colors, you've got two colors on your screen when you're drawing. You've got the actual outline, and we call it the stroke, and you've got the filling, which you call it the fill. Damn. I love it. So let's set, why am I shouting today? Let's add a stroke. Someone pick a number. Too late, 50. Cool. And we'll set a fill to, pick a number. Yo, you guys were ready. 170. I heard you. Cool. And then if you're not clicking this, how about we I can hear some people going, yeah? It's amazing, right? Shortcuts are your friend. Can you guys see that? Should I zoom in? Should I zoom in or can everyone see? You want dark mode? No.
The people in the front are saying we can't see.
I don't know what's going on with my cursor. Oh, there. Okay, cool. And now, someone said plus plus. Wait, what?
Control plus.
Oh, control plus. There. Can you guys see that? Is that better? Ah, okay. Cool. So you guys were suffering all this time and you didn't say anything. Okay, cool. So, as you can see, all we're saying is if mouse is pressed, stroke 50 and fill 170, else, let's swap these around. 170 over here and 50 over here. Right? Doesn't work. Why not? That's because we're only drawing our circle at the beginning. So we have to move this into our draw function so that it can be called constantly. And refresh. That helps, right? And you can see that when I click, it changes. Now, if I wanted to create paint, all I have to do is say that I want this to be drawn at the position of my mouse. Refresh this, and we now have a paintbrush on the canvas. But now that doesn't really look like a paintbrush because what are all those circles, right? To get rid of that, literally all I have to do is get rid of the stroke and tell it when it starts up that there will be no stroking here. And there you go. We don't have any stroking anymore. Quite cool, right? This is all fun in games. Or is it? So, in games, you often, or when you're creating 3D experiences, you often have to do some complex rendering. And lighting is one of those really difficult and expensive things that you can deal with. So we're going to do some lighting. Our last example for tonight is going to be some really complex stuff. We're going to have two balls that we're going to move to the sides, right? Then we're going to shine a light in between them. The light will be our mouse. Depending on where the mouse is, the light will shine differently on the two different balls. Cool. So let's get rid of this, because otherwise the code I prepared won't work. Cool. Ah, so much code. So as you can see, all we're doing there is we're creating a canvas, but now instead of using the 2D renderer, we're going to cheat and use WebGL, right? And then we're going to make the background black. We want some stroking for now, so we're going to comment that out. And we're going to fill it. We're going to use a fill of 200, which means whatever we draw, that's the color that we're going to be using. I don't know what 200 is. It's a color. By the way, you can make this RGB, so you can add 3 colors here, and it'll actually use RGB. Cool. Now our draw function. Every frame, we're going to calculate the direction of the light. Should we go into the maths? No. It's okay, guys. Cool. Trust me. I think I'm an engineer sometimes. This is what I want to show you guys. They've done a lot of the work in figuring out how to render all of that lighting. With WebGL and with P5.js library, this one line will create our entire light. That is all we need for the light. We then say, I want to translate the next thing that I'm going to create to the left, and then we create the sphere. I want to move the next thing I'm going to create to the right, and we create the next sphere. Do you guys want to see what this looks like? Check that out. And because we're dealing with a 3D object, and this is why I said we should allow stroking, ooh, the lighting is bad. See what I did there? You can see all those tiny triangles that actually make the 3D-like object, right? That give us that view of a 3D thing. And all you have to do to remove those is say no stroking, and now you've got these smooth surfaces that are 3D objects. P5.js, right? So they've got a whole range of utility functions that they've built that will allow you to create your normal native elements, such as your divs, your images, your image tags, sliders, and these are all, when you use these functions, they will actually generate all of these stuff that we usually work with on a daily basis as developers. You can pick up events like mouse released, double clicked, right? That's all built in for you. You can also have stuff like add classes. You can put all your CSS into your style tag, right? Or you can pass it into your style function to write the normal CSS that you're used to. You can also load sound and play it, and they have all these utility functions to help you deal with sound, right? The world feels. To show you guys the power of this library, I just navigated to a website. It's on localhost. I've had a server running on my machine throughout this talk. I built this sometime last year with P5.js, right? And what this does is, based on what you type in here, it'll pull up the top 100 tweets, perform sentiment analysis on each one of them, determine where the person that tweeted this was from, and then tell you how that country feels about the topic. So you guys tweeted earlier. Let's see what you guys think. Okay, so there's a couple of tweets, and it's all positive. Can you guys see those greens? Someone is tweeting from Saudi Arabia. Let's see who that is. Yes, I can also see your tweets. Thanks. Slightly better understanding of processing in the browser. And when you click on that, you can then go and view the actual tweet itself. Hey, Vaughn. Hey. Now check this out, guys. Now you can do some really, really powerful things with P5.js. So this globe literally just keep rotating to show you what the world feels. And you could subscribe to the Twitter API to constantly get updates as people tweet. So you could build this as a real-time monitoring tool for how the world feels about you or your topic. So if we go so if we search for that, it's probably all from South Africa. There's people are mad, or even better, right? If we search so
Hey, South Africa.
South Africa just doesn't even care, right? So you can get a flat so global warming, right? Right. We really seem to like global warming. But so, to cover tonight's show, we spoke about how good these slides look. We spoke about the importance of good looks. We spoke about just how difficult getting those good looks is, as we saw with the Mona Lisa. And then we saw how to get them with P5.js. Also, follow us on Twitter. Thank you very much.